Thanks for clicking on this video. If you want to follow along, the links to the companion worksheet are in the description below. Now today we're talking about permutations. Now permutations are a way of counting how many ways you can pick a certain number of items and put them in order. So here we want to find the following permutations. In this first one, P53, meaning out of 5 things, how many different ways can we pick 3 things and put them in order? And so the way we think about this is, well, how many different ways can we pick the first one? Well, that's 5 ways. Then how many ways can we pick the second one? That would be 4 ways. And then how many ways can we pick the third one? That's going to be 3. And then once we do that, now we multiply them. And so when we do, 5 times 4 is 20, times 3 is 60. Now with letter B, we take P20, 2. So out of 20 things, how many different ways can we pick and reorder 2 of them? Well, for the first one, there's 20 ways to pick the first item, and there's 19 ways to pick the second item. So when we multiply those, we get 380. Now letter C, here we have 2 different permutations. We have P26, 3. So that means I'm going to multiply 26 times 25 times 24. And then I have P10, 3. So that means I'm going to multiply 10 times 9 times 8. And so when we multiply all of that together, we're going to get, 26 times 25 times 24 times 10 times 9 times 8. We get a very large number, 1, 2, 3, 2, 0, 0, 0. So 11,232,000. Now when we get down to here, we want to put this in terms of N and R. And so what we have to do is we kind of have to go back up to the first 2 and rethink them. Because here we knew, okay, out of 5 things, we're going to use 3. So there were 3 of them. So we have 3 terms. Here, out of 20, 2, we had 2 terms. Same thing here. For P26, 3 and P10, 3, we have 3 terms. But down here for N, PNR, it's going to be N times N minus 1 times N minus 2, but we don't know how far to go. All we know is that there's going to be R number of items. And so we have to go back up to the top and rethink this a little bit. And the way we're going to rethink about it is using factorials. So how can we write this using factorials? Well, factorials start with a number and they multiply all the way down to 1. 5 times 4 times 3 times 2 times 1. You always have to go down to 1. That's where factorials enter. Now we don't want the 2 and the 1. So that means we're going to have to divide by that. So that when we divide, we're just left with the 5 times 4 times 3. So I can rewrite this with factorials as 5 factorial on the top and 2 factorial on the bottom. Now with letter B, same thing. I start with 20 times 19 times 18, ... I'm not going to write them all out. Times 2 times 1. All factorials have to go down to there. Now, I only want the 20 and the 19. So in the denominator, I should put 18 times ... 2 times 1. So that when I divide and cancel out, all that's left is the 20 and the 19. So on top I have 20 factorial, and I have 18 factorial in the denominator. And so looking at this, I see a similar structure. The number on top is that first number, 5 factorial, 20 factorial. But what about the second number? It's not 2 and it's not 18. How do I get 2 out of these 2? And how do I get 18 out of these 2? Well, if I take 5 minus 3, that gives me 2. And if I take 20 minus 2, that gives me 18. So that's the key right there that's going to allow me to write this for letter D. On the top, it's going to be n factorial, and then it's n minus r factorial. And so that's what this is right here. Now letter E, very similar. I have n on top, and then I'm going to subtract these. N minus r factorial. Now I'm going to simplify this a little bit because I can distribute the negative. N minus n plus r. So that simplifies and just leaves r factorial on the bottom. And so that's the formula for this one, Pn comma n minus r. Now here for number 2, we want to write these expressions using permutations. So here, I'm starting with 10 and I'm multiplying 4 numbers. So that's going to be P10. That's what the first number is. That tells us where we start from. And then the second number is how many we're going to multiply together. So this is P10 4. 10 is our start number, and the number of terms is the second. So for letter B, that's going to be 200. Now we have 200, 199, all the way down to 101. Now be careful, because this second number isn't 100, it's 101. And that's because if we start with 200 and count down to 101, that's 100. But then I add in 100, and so we get 101 there. With letter C, we start with n plus 2, and then it's 1 less, n plus 1. Then it's 1 less than that, and 1 less than that, and 1 less than that. So this is P, n plus 2, comma 5. So number 3, how many ways can you choose and arrange 3 letters from the group A, comma B, comma C, comma D, comma E? So there are 5 letters to choose from, and we are choosing 3 to put into order. So that means that there's 5 letters for the first, but then there's 4 available letters for the second, and then 3 for the third. And so this is the same as P 5, comma 3, because here's how many we have to choose from, and here's how many we actually pick and put in order. So P5, 3. Number 4, out of a group of 20 contestants, how many ways can you choose a first place winner and a runner-up? So for the first place winner, there are 20 choices. And then for the second place winner, there's 19 choices. So this is the same as out of 20, I'm picking 2. So this is P20, comma 2. Number 5, how many ways can you order 5 books on a shelf? Well, that means out of 5 books, we're using all of them. So that means for the first book, there are 5 choices. Then for the second book, there's 4. Then for the third, there's 3 books to choose from. For the fourth book, there's 2. And by the time you get to the last book, there's just 1. Now this is the same as P5, comma 5. Out of 5 things, you're choosing 5. Now this is also the same as factorial that we've seen before. And these two are going to equal the same thing. Number 6, how many different passwords are possible if there has to be 3 different letters and 3 different numbers? So if we're using the English alphabet, there are 26 letters. So there's 26 for the first letter, 25 for the second, 24 for the third, and then 3 different numbers. So there's 10 digits for the first number, then 9 digits for the second, and then 8 digits for the third. Now what I'm going to do is I'm going to break these up into 2. Because here we have 26, 25, 24, and then we have 10, 9, 8. So here, what are we starting with? We're starting with 26, and we're picking 3. So this is P26, 3. And then here, we're starting at 10 and going down to 3. So that's what each of these represents, and then we are going to multiply them. Number 7. How many different passwords are possible if there has to be between 4 and 8 different characters, letters or numbers? So there's 26 letters and 10 numbers, so 36 characters overall. But we don't know how many we're choosing. It could be 4 or 5 or 6 or 7 or 8. So if I just said if there were 4 characters, we would have P36, 4. But then we have to include, well, what about the passwords that are 5 characters long? Then it's 36, 5. And these are different passwords, so we have to add them. So then we include the passwords that are 6 characters long, and the passwords that are 7 characters long, and the passwords that are, whoops, that should be a 6, and the passwords that are 8 characters long. And so since each different length is considered a different password, we add them all together. And then number 8, it says find the value of n. So we're taking some number and then multiplying the next number beneath it, whatever it is, and getting 110. So the way I can think about this is, well, what is 110? Well, that's 11 times 10. So what number did I start with? I started with 11. And how many numbers did I multiply? I multiplied 2. So that means this is P11, 2. Letter B. Here we have P10, n. Now with this one, what we're doing is we're starting with 10 and we're multiplying until we get 30,240. So I'm just going to do a little guess and check here for this one. So 10 times 9, nope. Times 8, nope. Times 7, nope. Times 6, there we go. So that's what this equals. 10 times 9 times 8 times 7 times 6. So how many numbers are there? There are 5. So that is what this equals. P10, 5. All right. So this one, P500, n equals 1. Now with this one, I'm going to use that definition that we used for number 1, part D, and write it as 500 factorial over 500 minus n factorial equals 1. Now, 500 factorial is too big to compute on the calculator. If you try and do it, it's going to give you an overflow error. And that's the point, is you're not really going to use a calculator for this one. Instead, think about this. If you divide 2 numbers and get 1, what does that tell you? It tells you that these two have to be the same. Which means 500 equals 500 minus n. So in order for that to be true, n has to equal 0. So this is written as P500, 0. That means out of 500 things, we're picking none of them. Then there's really only one way that could happen. You get nothing. All right. And this last one, I'm going to set this up the same way. N factorial on top, n minus 2 factorial. So now I'm going to simplify this because I can distribute the negative and the ends will cancel. All right. Now 2 factorial is just 2 times 1. And I'm going to multiply that over to the other side. So 181,440 times 2 is 362,880. So some number factorial is 362,880. So let's try working our way upwards. Well, 1 times 2, 3, clearly not. 4, 5, 6, let's try that. Nope. So let's keep going up. Times 7, nope. Times 8, nope. Times 9, there we go. So n equals 9. So this is P 9, comma 9 minus 2. So this is P 9, comma 7. Thanks for watching. If you like this video, hit that like button, and if you want to see more, click the subscribe button. To support the channel, click the links in the description down below. Thanks for watching, and remember, the best way to understand something is to do it.